Okay, guys, today we're going to I'm going to kind of bring everything together so that way it kind of helps make a little more sense in what we're talking about. We're still talking about linear equations and linear relationships, something that we've been doing all year, but now we're actually putting it into practice where you're going to start seeing it in graphs. Businesses use these to determine how much money they make on product, whether or not their things are going well. It's used in a lot of different professions. You'll see it in a budget. You'll see it in several different things. And what we're talking about is what's called constant proportionality and constant rate of change. And the two words that are the same in both of those is the word constant. Constant means that it is the same. So what we're looking for things that happen at the same rate that that you can figure out over a period of time. And the only way that I can really explain this is let's say that you that for every apple, I'm sorry, for every dollar you spend, you get 2 apples. Or for every mile run, it equals 7 minutes. Maybe you're a fast runner. So the way that you would describe this is you would say that for every time I get $1, I get 2 apples. For $2, I get 4. For $3, I get 6. For $4, I get 8, and so on and so on. And I could figure out that for every 12, I get 6. So you're dividing by 2 each time. So you're taking your bottom number, you're taking the y over the x, because your x is always on top. 4 divided by 2 is 2. 6 divided by 3 is 2. 8 divided by 4, so on and so on and so on. So your constant rate of change is every time you spend another dollar, you get 2 more. That's how this works in the real world. So if we use this example here, where we're looking at for every mile for minutes, so x and y. So I run 1 mile, I go 7 minutes. I run 2 miles, I go 14 minutes. I could run 5 miles, and 5 times 7 is 35. It's going to take me 35 minutes to run 5 miles if I follow this constant rate of change. That's what this means. If we were to graph it on a line, you could see that if I ran 0, I'm not going to go any minutes. I'm just going to stand there. If I ran 1 mile, 7, 2 miles, 14, so on and so on. So there's the difference between that. Now, that's called constant rate of change. I'm sorry, constant proportionality. That means it's proportional. Proportional means that a proportional relationship means that it crosses 0, 0. This case, it crosses 0, 0. If I don't run, I don't go anywhere. If it's non-proportional, it does not cross at 0, 0. So an example of a non-proportional relationship would be something like like this. Um, uh, Tickets to a theater are $3 a person plus a $5 parking fee. So you're going to the theater, you have to drive your car, you park, they're going to charge you $5. No matter what, one car, $5. But then you are charged $3 per person. So to figure out how much you would spend, you would write something like this. Okay, if I take 3 and I multiply it by however many people I have, because X is the number of people, and then that's your dependent variable. Um, and then I'm going to spend $5 for parking. I will know how much I could spend. So I can take, if I wanted to, I could say, okay, if I took 2 people, that's going to cost me $6 per ticket plus $5, and that's $11. So that's how that concept works here. So this is still in the same kind of form as y equals mx plus b. And that's how we get that. This does not have a constant rate of change because, I mean, it does have a constant rate of change. It just does not go through 0, 0. Because if I bought one ticket, I'm going to, no matter what, one ticket is going to cost me $5 extra for parking because I'm going to the theater. So here's how this works. Oops. You have two equations. You have y equals mx, and you have y equals mx plus b. The two things that you need to remember, make sure you've got this written down, is that this is proportional and it goes through 0, 0. This one is non-proportional and it does not go through 0, 0. Let's go ahead and label this. Write this in your journal. Oops. Oops. Boy, I can't. Right. You've got y equals mx plus b. This is your rate of change. This number right here tells you where it crosses the y-intercept.
Slope-intercept form equation.
So this is, all that means is it crosses y-axis somewhere. So this is your y, that's your x. If it crosses here and that number is 6, then that number is 6. If it crosses there and that number is 7, it's 7 there. If that crosses there and it's -9 or -8, that's a -8. That's all that means. This x The x is your input, because if I plug the x value in and substitute the x value, I am going to get an output y value. So let's see how this works together. This formula this thing I came up with up here of tickets are $3 a person and there's a parking fee. So it was y equals 3x plus 5. So I was able to write an equation. Oops. So that's $3 per person plus $5 parking. So if you look at this, it's got the same look as this. So it's the same kind of look. That's where we're grabbing that formula from. So let's put that in a table. And the way I'm going to do that is kind of separate it out. I've got my x's and my y's. And I'm going to say that if I take 3x and add 5, I should be able to get this y value. So let's make up some numbers. So I'm going to make up some numbers for x, because I could take one person, I could take 12 people, I could take 500, I could take 2 people. But let's go with simple numbers, and let's substitute those numbers in. So 3 times 0 plus 5. Well, 3 times 0 is 0, and plus 5 is 5. Oops. I'm trying to use the same colors. Let's do the next one. 3 times 1 plus 5. Write all your equations in. 3 times 2 plus 5. 3 times 3 plus 5. So when I would go work that out, 3 times 1 is 3, plus 5 is 8. 3 times 2 plus 6. 3 times 2 is 6, plus 5 is 11. 3 times 3 is 9, plus 5 is 14. So what's happening here is that every time I add a person, my cost is getting more by 3. So the other equation you have, m is your change in y over your change in x, which this is your slope, or your constant rate of change, or your constant of proportionality. It's called several different things. It doesn't matter. There's just a fancy word of saying that things are happening at a constant rate. So let's take those numbers. And you know that the y is a 3, And you know that the x is a 1. So your constant rate of change is 3. So for every time you add a person, you're going to add 3 more dollars to what you're spending. Now we can go graph that. And if you look at my graph, if I take these coordinates 0, 3, because there's my x's and there's my y's, 1, I'm sorry, not 3. If I were to take my x's and my y's, so 3, I'm sorry, 0 and 5, 1 and 8, 2 and 11, and 3 and 14. And if I were to graph those, I'd start at 0 and I'd go up to 5. I go over to 1 and go to 8, 2, 11, and so on and so on. And if I were to draw my line, it does not go through here. So since it does not go through 0, 0, it's not proportional. And if you look at this line, this first point is 0, 5. It's crossing the y-axis at 5, which is what I told you that number would be. So that's how all of this connects together. Simple way to remember anything. If I gave you this equation right here, the slope is 2 over 1 because you take your change in y over your change in x, and that's 2, and you don't know what this x is because they've already simplified it for you. So your slope is 2. Your m is 2. Your constant rate of change is 2. Your constant of proportionality is 2. Everything is 2. Your y-intercept is 3. That's how simple it is. So, equation. Y equals 2/3 x plus 4. Your slope is 2 over 3, and your y-intercept is positive 4. Slope is 1 over 3, and your y-intercept is negative 2. That means if I were to plug in numbers and graph that, that would end up going through the negative part of the y-axis. A lot of students don't like to see the fractions where the bigger number is on top, but when you're working with slope, it's super simple. The slope is still 3 over 2. The y-intercept is 1, positive 1. And here's another example I'll give you. Now this one here, you have to take a little bit look at it, and 18 and 9 can go into each other. This is where you have to remember to simplify. 18 divided by 9. Oh, totally lost my train of thought for just a quick second. Anyway, 18 divided by 9, your slope is going to be 2 because 18 divided by 9 equals 2. And your y-intercept is -3. Okay, here's a couple of examples. Those are all constant rate of change. They do not go through 0, 0. So if it looks like this, it is not going to cross the origin. But if you have one that looks like this, your slope is 2, and your y-intercept is 0, 0. Doesn't go through anything. It doesn't go through through any other number. If I have y equals 3 over 2x, my slope is 3 over 2, and my y-intercept is 0, 0, which is the origin. Slope is 6 over 2. When you divide that out, that becomes 3, and my y-intercept is 0, 0, because it doesn't go through anything but the origin. And that's because there is no plus b. There's no plus number, there's no minus number. So there's the difference between those two. When it says to check it, all that means is that you're going to take what you have done here. You checked it. You put 3, you plugged in your numbers, 3 into 0, get 3 times 0 plus 5 gives you 5. When I did that, I got my x and my y value. That's all it means by check it. I hope that helps out a little bit. I hope you've got the notes. If you have any questions, let me know.